look at finite state machine. It's a simple sequence detector, 1, 1, 0. You can even try this example. This has inputs, sequence underscore in, clock, reset. There are 3 inputs and 1 output. Everything is single bit. And this is how the FSM looks like. There are 4 major states: idle, S0, S1, S2. In S2, you are going to get output 1. This is how the transitions are going to be. You can analyze this FSM later. How you can write the source code: module, sequence detector, all the ports are wire data type. So define the directions, input, output. Here, there are 4 parameters. I want you to remember this. For any FSM, you have to define parameter. Here, how many states? 4 states. So there are 4 parameters. And then you can define the values: 001, 0010, 0100, 1000. So here, we are trying to use one-hot encoding. This is slightly different. Here, only 1 bit is high. It's called one-hot encoding. That's why we are using 4 bits. Otherwise, 2 bits would be enough. Okay, fine. Now let's look at. There are 4 states, so 4 parameters. You have to define 2 variables: present state and next state. And the width is 4 bits. Here, the parameter size is 4 bits, so you have to define the variables as 4 bits width. Always at passage clock. If reset is high, present state must be idle, else present state must be next state. This is called state transition logic or present state logic. If reset is high, present state should be idle. The FSM has to be initialized with idle state, else the present state should get the value of next state. We are using non-blocking because this is sequential logic. This is sequential logic because there is a clock in the sensitivity list. Always at sensitivity list. This is combinational. It's called next state logic, next state decoder. To produce next state, we need 2 things. One is present state, the other one is input. That's how we are going to define the transition. And then you have to make the default assignment because this is combinational. Case, sample the present state, and for each present state, you define the transition. Here, for idle, for S0, for S1, for S2. We covered all possible states. So basically, in next state decoder, we are defining all the transitions. And the next state decoder logic is going to produce the value of next state based on 2 things: present state and input. So here, based on input, you can define the transition. This is next state decoder logic. And there is one more block called output logic. So here, the output is high only when the present state is S2. This is ternary operator. Present state is S2. When this is true, output should get 1, else output should get 0. This is how we define the output logic. This is how we create the FSM. All right.
Thanks for watching this video. Thank you.